In this video, we are going to do 25.02 Multiple Space Invaders Part 2. Alright, so this is what the solution is going to look like. It's going to be the iteration of the previous video with multiple space invaders, except this one is more like the original, right? They all move left and right before they move downwards, and they have this gridded-like fashion, right? And of course, we can shoot them down like so, alright? So if any one of them reaches the bottom, like these two over here, touch the bottom, it's game over. And also notice that they all travel in the same direction, right? So they're all traveling right, and then when it hits this right edge, they all travel left, right? They're not traveling each individually in the x-axis, all right? All right, so let's just move on to the starter file here and scroll down to the problem statement. So where is the problem A? Right over here. All right. So problem A says, carrying on from 25.01, expand Space Invaders to behave like the original. Spawn enemies in a gridded-like fashion and move them side to side before moving them downwards. This starter file contains spoilers as to what to do. Challenge yourself by starting off with the 25.01 solution file. All right. So this is the 25.02 starter file. And again, there are some spoilers here. We give you the data representation as to what you need to add, what functions you need to modify, what functions you need to make, and it's very like step-by-step instructions. But I highly recommend that you guys challenge yourself with the 25.01 solution file and just work from there and come up with things from scratch. Because in the future, you're not going to get a starter file that conveniently tells you, hey, you have to do this, this, and this, and we've already done this for you, right? You're going to have to conjure up things from scratch every time you want to add a new feature. But anywho, for the sake of time, and so that I don't ramble and the video doesn't get too long, we're going to start off with a starter file. So making the invaders move sideways requires the game to have an invader-vel-x field, which has been done for you, alright? So let's just look at the game structure over here. Define struct game, and here is the invader-vel-x. This field has been added for us. And there's the number like so. And what does that represent? Well, it represents the x direction the invaders are traveling. So -1 means left and 1 means right. And 0 means that they're not traveling in the x direction. All right. So this has been done for you already. If it's not done for you, right, you add this field in, and then you would have to go look at every instance of make game and add that number over here, right, where invader-vel-x is. So right before the score, you have to add that number. But for the sake of time, it's already done for you. So we can move on to updating the functions like so. So let's look at the functions that we need to modify. Update-menemy, all right? So we need to modify that function. So update-menemy right over here, right? So pause the video and try to guess what you need to do to update menemy to fit our new requirements, moving the invader left and right. Alright, I'm going to assume that you guys took a good swing at it, so now let's go over it together. So the old purpose statement says that it moves the enemy Y position by the enemy speed. Now we also want to move it left and right, so we also have to move it by the X position. So the new purpose statement has to say moves the enemy X and Y position by the given velocity, alright? So that means we need another point here to represent the velocity. And also the signature should reflect that, right? Here's another point. And this is essentially going to be the point add function. So given 2 points, right, one of them being the invader and one of them being the velocity, right, we can say that this is the velocity, this is the invader. We want to add 40 plus 3, right? That's the vel-x, and then the vel-y is 2, so it's going to be 32, like so. So this is just going to be a very simple function, adding the 2 points together, right? The invader and that of the velocity here, right? So this one right here is going to be point dash x of the velocity. And then this one over here is going to be point dash y of the velocity. All right. So let's see what is the point. Here we go. All right. And that should pass that test. And that is update-menemy done. Now let's move on to the next problem. Update all enemies, right? This uses update-menemy. So you can imagine what we need to do to modify this function. Spoilers in 3, 2, and 1. Alright, I'm going to assume that you guys took a good swing in it, so now let's go over it together. So it moves all enemies in the given list by the given velocity. So that is going to be the new purpose statement. So we need to add the given velocity here, and the given velocity is just a point. And if you run this code actually, it's going to say, hey, update-menemy, the one that we just updated, requires 2 arguments, right? 2 points. So we have to pass that down like so, right? We're going to be given a velocity here, and we just pass that down. And that is pretty much it for update all enemies. It's just the plural version of update a single enemy, except in given a list, we produce a list with the updated velocity. All right. So now let's move on to the next problem, which is that we're going to need a new function called enemy hit edges to see when they touch the left and right edges. Remember, right? It only switches positions when it hits the right edge or the left edge, right? Like so. And that is what we'll need this function for. All right. So, and enemies hit edges consumes a list of points, which is really the list of enemies, and produces a boolean. Produces true if any enemies in the given list touches the edges. And here's the stub. All right. So pause the video and try to do this on your own. Spoilers in 3, 2, and 1. All right. I'm going to assume that you guys took a good swing at it. So now let's go over it together. So let's actually write some tests for this. Check expect. Enemies hit edges, let's give it where it hits the right edge of the screen, right? So there's an invader here that's hitting all the way to the right edge over here, right? So that's what's happening. So here we go, make point. We're going to add 1 to the width of the canvas, and then the Y position will be 0, and this should produce true. All right. I think I put this in the wrong parentheses block. There we go. All right. So that's this one single enemy hitting the right edge. Let's make another enemy actually, right? So that we have we're testing a list at least too long, right? So we'll say 20, 30, right? This one's not hitting the edge, and this one is hitting the edge, so we should still produce true. All right. Let's do one where it's not hitting the edge. So we'll say this is at 50, right? This should produce false. Neither of these entities are touching the edges, the left and right edges of the screen. All right, let's do it where it hits the left edge, because this is the right edge. All right, and this is the right edge with 2 enemies, and this is the none, right? None of them are touching the edge. So we need one that is touching the left edge. So we can say this is -2. All right, and this should produce true. All right, so hopefully this is all the mental scaffolding needed to solve the problem. Let me just write out the list template for enemies hit edges, right? We're consuming a list of points, and it should be familiar by now that we have to write the list template, right? Every recursive function that processes lists goes through this sort of structure, right? Checking if the list is empty, and then doing something with the first of the list, and then the recursive call to the rest of the list. Okay, and there we go. Now really pause the video. Hopefully this should be all the mental scaffolding needed for enemies hit edges. I'm going to go with spoilers in 3, 2, and 1. All right, I'm going to assume that you guys took a good swing at it. So now let's go over it together. What should the base case be? If there are no enemies in this list, right? So no enemies are alive. Are they hitting the edges of the screen? Well, that should be a no. All right, so we should produce false. Next comes the hardest part, what to do with the combinator and the first of the list, which is going to be a point, which is going to be the enemy, all right? So if any of them touches the left or right edge of the screen, right? So this one's not touching them, this one is touching it. So it kind of screams an or here, right? It doesn't matter if there are 100 enemies in this list, as long as one of them touches the left or right edge, then the space invaders have to move left or right. So we just use an or here, right? And we need to test if it hits the left edge, which we can get the point-x of the invader, and then say, are you less than 0? So less than 0. All right, this tests if it's hitting the left edge, right? If your x is less than 0, you're hitting the left edge, right? Now let's do the right edge, right? So I'm gonna copy and paste this, like so. And to test the right edge, we're gonna have to add the enemy x, enemy's width, right? So Let me just add it first and I'll show you guys what I mean when I diagram it out. So we're going to take the X and then get the enemy image width, which is the constant defined above, and say, is that greater than the width? All right. So this width of the screen. All right. So this tests if it hits the right edge of the screen. Why are we adding the image width? Because the origin of the image, the alien, is right over here, right? So I'm going to add the width to make sure that this touches the right edge. All right. And that is pretty much it for enemies head edges. All right, so we can factor this out. See this repetition here? Point-x of first enemy LST, point-x of first enemy LST. We can factor this out into a local variable. So local, I'll move my braces here, and then we'll define enemy dash x, and then just paste this there. All right, like so. And we can just use enemy x in that position, right? Everywhere we see this. All right, same code, but shorter to right. So enemy dash x. Let's see, expected. Oh, we have to put this right inside this local so they can use the variables. There we go. All right. And that is enemies head edges done. All right, so now let's move on to the next function, spawn enemies gridded. So it's all the way down here next to spawn random enemies. So spawn enemies gridded consumes two numbers, so the row and columns, and they produce a list of enemies, which are just points. Produces a list of enemies positioned in a grid-like manner given the rows and columns. All right, note the origin of the enemies are at their top left corners. All right, so let me just diagram this out to show you guys what I mean. So you go to TLDraw. Go to preferences, show grid, right? We need to show grid here. All right. So what does it mean by positioning them in a grid-like manner? Well, let's just draw some lines here. Hopefully you guys can see the black dots over here, right? These black dots, because I need to display a grid, but nonetheless, right? So this is 0, 0, right? 0, 0. And each invader, I'm going to copy and paste one down, is going to be positioned in a grid-like manner, right? Like this. In their own little cells. All right, gonna drag this down. Let's say we're gonna make it 3 by 2. So something like this. Like this. Now I can just paste one. I don't know why it's going to that other box, but nonetheless. Right, we want this grid-like pattern. All right, so the rows and columns is 3 by 2. Right, 3 by 2, 3 columns and then 2 rows, but nonetheless. All right. So this invader, the first one is at 0, 0, right? The top left origin is their X and Y coordinate. This one, let's say that each individual grid cell is 5 by 5, right? In the real version, we're going to use invader width and height, the image width and height. But we're just going to say each cell is width and height by now of 5, right? Just to make addition easier. So this invader's position is 0. No, it's 0. Wait, no, it's 5, 0, right? Because it's 5 to the right. And then this one is 10, 0. And you can imagine this one is going to be 0, 5, 0 in the X direction, 5 downwards. This one is going to be 5, 5. And this one is going to be 10 and then 5, right? 5 downwards, right? So this is these 3 invaders have a y of 5 and an x of 0, 5, 10. And these one have a y of 0 and then 0, 5, 10. So essentially we're going to need these coordinates. We're going to produce a list of points with these coordinates 0, 0, 5, 0, 10, 0, 0, 5, 5, 5, 10, 5, except the 5s in this case. Right, instead of incrementing by 5 and 5, we're going to be incrementing by the width of the invader. So the width of the invader, and then the height of the invader, right? So hopefully that does make sense. All right, so pause the video and try to work through this on your own. I'm going to go with spoilers in 3, 2, and 1. All right, I'm going to assume that you guys took a good swing at it, so now let's go over it together. So let's just write a test for this. So signature purpose stub, examples. Let's just write one test for the sake of time. Check expect. All right, spawn enemies gridded. And then we're going to say 2 rows and 2 columns, all right? So this is going to produce a list of points, right? Which are the invaders at the given positions, right? So make point, we're going to multiply 0 by the width of the invader, which is stored in the constant enemy image width. And then the height is going to be times 0 enemy image height, right? And then the other 3 are just going to be variations of this with this changing, all right? Because we want to produce those grid coordinates. All right, 2 and 3. So we want to move 1 in X and 0 in Y. So we're making a 2 by 2, right? And then the next one is going to be 0 and 1, like so. And then the last one is 1 and 1, all right? So let me diagram this out, right? Let me do it up here, right? So this one is going to be invader here. This one is this second invader. And then this third one is going to be 1 over here. And then this third one is going to be 1 there, right? So these are the numbers of the grid coordinates times the dimensions of the invader width and height. All right, so now that we have a test, right, hopefully this is all the mental scaffolding, all of it that you need to solve this problem. Over spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it, so now let's go over it together. So we need rows and columns to stay constant because they tell us when to stop. We want to stop at 2 rows and 2 columns, like this. So we don't want to create a 3 by 3, etc., right? If they're not constant, we don't know when to stop, and therefore, it's going to create 1 extra. So we need these to be changing. So essentially what we're going to need is a helper function. All right, so local, and then we're going to call this define spawn, and this one will keep track of the changing X and changing Y. So this is the current X and current Y, and this will be representing the changing X and changing Y over here, right? 0, 1, and then this also, the Y is changed to 0, 1. All right, so this function consumes a number, and produces a list of point. All right, so we need to do a cond here, and we need to know when to stop. So we're going to stop when the current Y is greater than the rows, right? If so, we're going to produce the empty list, all right? So if the current rows, so we want 2 rows, we don't want a third row, so stop at the second one, right? Like so, all right? And then we need the else case for incrementing the X, right? So cons, because we need a list of points, we're going to build a list with cons. Cons of what? Well, we want to make points, so we need a make point over here. And these zeros and this one over here is going to be CX and CY. And CY. All right, so what do we want to cons this on top of? Well, we want to eventually hit this base case, and we need to decrement the current Y, right? Like so. So we're going to call spawn 0 and then add CY1, right? Because notice the zeros does eventually turn into a 1. But we're not done yet if we just write this, right? It's not going to work because the X's also need to change, all right? And they change when the column is greater than 2, right? So 0, 1, and then we move on to the next row, right? So after I'm done with the first row, first column, second column, all right, don't do a third column, move on to the next row, right? So that essentially means that we need an if here. So we need an if, because we only want to move on to the next row when we're done with the X's, right? The horizontals, right? The columns. So if the X is greater than, we need to subtract 1 from the columns, right? By 1, right? So we're like 1, 2, after that, right? We want to move on to the next row, right? So this is going to be that, all right? Otherwise, right, we want to increase the X by 1, and then the Y stays the same, all right? So notice that the Y stay the same, right? 0, 0, 1, 1, and then if there was another one, it would be 2, 2, and etc. But nonetheless, right? So this is the final answer, right? We only want to increment CX by 1 if CX is, current X is not greater than the amount of columns, right? It doesn't exceed this, right? All right, so we're almost done here. We need to call this local function spawn 0, 0. And this should be the answer for spawn enemies gridded. All right. So now let's move on to the final stretch, which is modifying the update game function to handle the invader velocity. So where is my update game? Here it is. And this is where the invader-vel-x velocity will go to, right? So what do we need to do? Well, we need to detect when they're going to hit the edges of the screen and then move them left and right, right? Move the enemies left and right. So essentially what we need to do here is that we need to, right over here, detect when an enemy has touched the edges of the screen, right? Because if one of them touches the edges of the screen, then we got to negate the vel-x to move to the other side, right? And then also move them downwards, right? Remember this motion? All right. So we just wrote the function for that. So define hit edge, we're going to store it in enemies hit edges, and we're going to call it with the game dash invader. All right, so did any of the invaders hit the edges, right? And we're going to store it in the hit edge question mark variable. All right, if they did hit the edge, then we want to, of course, determine the velocities, right? So define new invader-vel-x, right? If hit edge, right? If they hit the edge, right, then we want to negate, we want them to go to the opposite direction. So we multiply by -1. So game invader-vel-x of the game. All right. So this means that if they were moving right, well, now they're moving left, right? Multiplying by -1 negates their direction, all right? Otherwise, we want them to essentially stay the same, right? The same, keep going the same direction until you hit an edge, all right? So that is that done. Now we need to pass it to the moved enemies, because update all enemies now takes 2 arguments, right? It takes in the invaders, list of invaders, and then the directions we want to move them in, all right? So what we need is that we need to provide the velocity, which is going to be a make point, essentially. Make point. All right, I'm going to put it down here, actually. All right, so we want to move it by the new invader-vel-x, right? This is if they hit an edge or not, right? If they hit an edge, then we move the opposite direction. And we also want to move them down, right? If they hit an edge or not. So we're going to say if hit edge, right? If any of them hit the left and right edges of the screen, then we'll move them down by like 10 pixels. Otherwise, don't move them down at all, right? So I'm going to factor this out into a variable called y-vel, right? And we'll say define y-vel is equal to this. All right, whoops, I didn't close the parentheses there, so get bad indentation. This one, there we go. All right, control I, there we go. And that is moving the enemies by the velocity, right? The new velocity, if they hit the left or right edges, we negate their x velocity. And also we have to increase their y, because they got to move, right? After they touch the edges, bam, then they all move down. And then like so, right? Down only when they hit the edges, right? Okay. Almost done there. We also have to provide the new invader-vel-x to the updated make game function over here. All right, and that should be about it. So let's just run this code. And looks like it froze. We got an error. Update all enemies expects 2 arguments, only found 1. So this function takes in 2 arguments, and we're not giving it the second argument. Whoops, my bad. So I must have rushed through that. So there we go. And there we go, like so. All right. I think there was a bug by the spawn 2x2 grid. Well, wait. Just go down. All right, I said I want. This game has four rows and 3 columns, right? So 4 rows, 1, 2, 3, 4, and then 3 columns. All right, yeah. So this function, start game grid, given an x and y, we call a main with the make game centered with the spawn enemies grid x and y, right? So okay, so this was right. Right, so yeah, this is pretty much expanding the previous Space Invaders game to have a gridded movement, right? With however many, with this grid-like movement where it touches the right edge and left edge, and then it moves down, right? Then it moves down. And of course, there was only 10 pixels. You can increase that to, we'll say 20 pixels. And let's say we want, let's say 5, 6, right? So there we go. That's a lot more invaders. And there we go. They're moving 20 pixels down. All right. And of course, a lot of things can be improved here, right? This 20, let's make it, 30, let's make it 40, right? We can also factor this out to be a constant so that we know what it is. But, yeah, it's a move for a lot further down. But nonetheless, right, this is the final game. If any of them touch the bottom, right, then it's game over. Right, so like so, if this one touches the bottom, then it's game over. And yeah, all right. Anyways, congratulations for making it this far. We went from 0 to Space Invaders, and you can expand on this example and challenge yourself by, let's say, making it so that it takes 3 shots to kill some stronger invaders. Well, that would require the invaders to no longer be make points. They would have to be invaders that store a health field, right? They can't be simple points anymore. What if we want to fire multiple bullets? Well, this false over here, the data representation for bullets in make game would have to be a list of bullets, right? List of points for the bullets flying, all right? What if we want the invaders to move faster when there are less of them, like in the original Space Invaders? Well, we might need to store another variable here, right? Like so. And yeah, a lot of things that you can do to expand on this and challenge yourself. But nonetheless, that is about it for this one, and I will catch you in the next one.